in August, it's like, and it's like 60 degrees outside, and it's still, there's just no, it is. And this is the biggest classroom. And again, I'm not an engineer or an architect, but logic, well, I mean, this is science. I'm just in my office for 12 years. And every summer, 12 years, there was and you know, it was so awesome. And I'm just like,
yeah, the semester before I was a teacher, 60 hard. And so I started there, I didn't feel this, I feel it. I was here and administration for IT because not some more like the first time. And I did online and I was in the I was you know, obviously we kind of like a for short and I kind of set up stage two of my age to it on
yeah, yeah. As a teacher, because I have always taught computer things, okay? Because I was the web teacher in program teacher. I would go and I'd be like, I can't even think, and I can't even think. Forget just writing code because that's not going to happen. When I'm really hot, I'm so uncomfortable. I'd be like, I can't even process it to be able to teach them like that. And it's hard. Morning, guys. I have no idea. I'm sure it's going to talk to me, but I'm a just-in-time learner. I learn it just in time to use it, so I don't have no idea what that is. Yeah. I don't want to explain the work here. I know that these right here, you can toggle different presentation styles with these. We never use it. So what we use is the sampler PC, which is PC, and some of these, this is an app for the video, we have to live. So we're kind of forcing the square root of the rental because we're only part of the function. And so really some of these things they do in other systems called call.
So it was electric. Yeah.
Or
basically just get the equation.
yeah, I didn't ask yesterday, but yesterday's final example where you were talking about the absorption of water with the condensation or whatever. All I could think of was Sierra Nevada Brewing. Okay. And I know that I have that bit with left mine. I'm like, okay, that's not a field, that's a motherboard. Yesterday it was all about breweries.
Yeah. You know where you were this weekend.
Yeah, you know where I was this weekend.
That is something up there, though.
Oh, I love it. It's fabulous. It is, yeah. Maureen and I went, I was in Asheville for a week for a distance learning conference, and she had to come up to Asheville and make a presentation. And so I thought, well, I'm in Asheville too, so let's meet for dinner. And so we rode out to Sierra Nevada and had dinner there in the brewery. And then it was just, nice to get away.
Boy, it is, and it's even nice for like just a day trip.
Oh, yeah,
You
yeah.
know, it's so much there too for family, but it's nice.
Well, we both have annual memberships to Fieldmore. So,
Oh.
yeah, so we do, like, it's not that expensive, but it's a nice day trip. There's a lot to do on the grounds now. And she and her son take their bikes there and ride on the bike paths. And I take my grandchildren for free. So we'll go meet every now and then at the lodge and get afternoon tea or at the winery for samples.
That place really changed and grown over the past couple of decades.
It has. Yeah. It had, when I was working for college, I was kind of long. So vacations were hard to come on. So we would always do our vacation. And it's going one day for the is expensive. But if you do a season pass, it's 1.5 times in bigger than that. And you have unlimited destinations. So and right now there's a sale going on. I think it's like maybe about $2 or something. And every now and then, like in January, if you can go and get in and then pretty much it's so close. But that's what we're just going to go for a day. It is very expensive. But we're going not this week. We found a hotel that's converted meal. And it's on the river. And just, to hang out with lunch and then help us. The lodge, each room is like a little sweet kitchen. And then we're going to work. This time, so here's lunch on Sunday. There's all that. So I think it's just a week. I've not been to this cafe, but Tiffany, they've all raved about some of the food. We'll just stop on the way side. Well, my granddaughter's birthday, we She was turned off. And it was fine. That we put this in July, which is 6 months. So we did a whole. So what was the yes. I said, I'll know that I will set up dinner time. But
All right, you guys are
We should be
unmuted.
a -3 for talking and asking jokes and stuff.
Are you okay?
Just as a random 3, I could have understood if you put a -3 for not
No, it's just there.
So as I was doing that one problem where I didn't take the square root of 4, I just was sitting there like, why did I do that? So I gotta do all this over again because I didn't do that. And then I thought my little timeline looking thing would suffice for the concave up and down, but you wanted me to write out the intervals.
Yeah, I had that on my list, like 6 times, right intervals, right intervals, right intervals, with like 6 explanations.
Nice points, right coordinates.
Yes, I had points written everywhere.
-1 and -5, but not 3.
This Peter, do you think I should email him about how I got 16
I
extra
had
points in my grade to
because-
move at all?
What the heck? I think if you're worried about it, you should. Same.
Okay, I didn't write my email to that woman who's going to be interviewing
I got
me.
7.
I'm terrified. What if I misspell something?
I have got
For the
86 in this class.
I mean, I can pretty much say I'm not gonna win, but I might as well try.
No, like, how did that?
I don't know. I have to email her. and
How
do
did that
It's
happen?
probably gonna be in December.
I knew I missed 12. I was
That's what
supposed to
it
get
is.
all
Well, it could have still been, well, I mean, they all say their words. They all say it.
Oh,
It could have been that they just didn't read.
Okay,
I gotta swap cards with that.
did you understand
The
truck
truck
43?
I'm so happy.
Do you like the truck?
Oh my goodness, I love the cars.
Really?
My grade there were like so
Except
close
for
to
when
the
I was like, there were.
It hurts my dad to get in and out. That's how small it is. So when I sit in the truck, I'm like, oh
See, the
God.
Jeep's like a medium size
saying
car.
the
I
same.
think he might be mistaken about that. It's pretty great, because I saw the messages that were popping up.
I might have to
like it,
And it said something about
I just
we're doing
the seats and
restart
everything.
your,
So I won't.
I like the truck.
or reset, it says reset. See, our truck's like,
Because I think I knew about the lunch.
I know,
Yeah.
like Dad got it before my parents got engaged.
Oh my goodness.
And Dad proposed to Mom in the
The
truck.
teachers are there, and they might not be able to help us a lot, but they can help us sometimes, and I'm willing
That
to
is so cute. You'll never lose that engagement place as long as you keep the truck. I mean, like no chance of the building being torn down or something. It's like you have the truck.
It's pretty old.
Just keep the parts.
Just keep the engine.
What you do is when the truck can't take it anymore, deconstruct it and then make a new vehicle. With your
With
mechanical
the same engine? What if the engine
use your mechanical engineering degree to fix it.
That will be for a while, Sammy. That's okay, the Jeep's so cute. Oh, and like, I remember when I was little.
Dude, I found candy today.
Nice. And this still happens,
What's this?
but my parents would drive to the bowling alley. And I would be asleep for the car ride, but I would wake up as soon as we hit the parking lot. And then I would wake up when we get home.
The corrections.
It's like, and we think that he might.
Did you get that?
Well, let's see. Is this not graded?
The graded version should be somewhere.
Let's see.
Did your grade go up, Rizzo?
I don't know.
Mine?
Hey, yeah, pretty good. You do.
Like, you got points for
Yeah.
Did you check your grade this morning?
Did you check
Like,
your
I got
grade?
16
No.
points extra credit and my grade didn't move. Like, not even.
Well, I mean, there's a lot of points.
But mine moved, and I didn't do anything. Did you bring the candy?
Okay, so you should have your test rework corrections back.
Wow, these are.
On ahead and update updated the grades.
Long one?
I had updated the grades on Moodle to reflect that as well. So today we need these see what questions we have for our test tomorrow.
Are you okay?
So what's on the test? Two problems that will be optimization. Problems that will be related rates. No definitions, no proofs.
Proofs?
All you have to do is be able to write the equation and then do the work like we've done in class. Demonstrate how to apply calculus to do optimization and for related rates. So, that's what's on the test. Oh. Which section? 3, 21, and 33, I heard. Okay, so we'll look like 4. 33. Okay. 21 and what'd you say, 33? And then, okay, 21 on page 287. Find the dimensions for each shape so that the total area enclosed is as large as possible, given that the total edge length, is 120 inches. The rounded shapes are half circles, and the triangles are equal. 21 looks like sort of like a rectangle with semicircles on the ends. Oh, yeah. So 3.4, number 21. You have a picture, something like this given. Racetrack, I guess, or something. I don't know. What was the total edge length that was given? 120 inches. 120 inches. Okay, so our objective here is to maximize area. Our paint is the distance around the edge length, total edge, 120 inches. And then we need some kind of domain to go with that as well. But as typical, we can't really write the domain until we know what the equation is, what the function is.
Mm-hmm.
So, area. They didn't even label any numbers on there for me. I mean, I have to start from scratch. Let's call this dimension here X for sake of argument. What other dimension might I need to find the area? Looks like I might need to know this dimension as well somehow.
Yeah, can you call that D for diameter?
What do you call it? D for diameter? Mike? That makes you feel more comfortable. Hey, well, what's the area then? Let's start with writing an area equation. So we need something about area going on guess if I thought about it a little bit, I might see that this is,
There's a rectangle and a circle.
how do you visualize that area now?
Rectangle with two.
Yeah, that's equal to a rectangle plus 2 semicircles.
Could it not just be one whole circle?
Since those 2 semicircles on the opposite ends of a rectangle, but yes, they're equivalent. So yeah, I would say that that's just a rectangle plus a circle. I would agree with you.
Yay.
Here we're making progress. How do you find the area of that rectangle?
Length times D.
That would just be x times d, I guess. Okay.
Yes.
Oh my
I did it.
Well, the circle area.
I'm so proud of that.
What do you want that?
Pi times the radius, which is d over 2 squared. Now we've made some progress. We have an equation that looks pretty algebraic. The only thing I see wrong is I've got 2 variables over here, an x and a d, and I need just 1 variable. Everyone understand how I got to this point?
Mm-hmm.
Over 2 is the radius, and you got to square it to get area of the circle. Okay, I got to relate x and d somehow. The way we did that, so you got a d and an x, you got 2 variables in there. The way we did that previously was we used this constraint somehow. What does that constraint tell me? Yeah, so the total perimeter equals 120 inches. How do we figure out that perimeter algebraically?
Oh no. What's the circumference of a circle again?
Pi d.
Pi d.
It's pi r. And certainly 2 x's we got to account for. And as Reza was saying, you got to go around the edge of a complete circle, which is the circumference of the circle, which is pi times d.
Yay.
Fun to solve for. Doesn't really matter. Any meaning. Let's solve for x. You want to solve for d.
Well, if we solve for d, we can divide out the pi, but I don't know.
Let's solve for x because I feel like.
Okay.
So let's see. That means 2x equals 200 minus pi d. X equals 100 minus pi d over
That's
2.
120.
You know,
It's
I'm gonna say
120, not 200.
I'm gonna say it's 120. Just
Oh,
put that out there.
120 instead of 200. So that makes us 60. Is that better now?
Yeah,
Yeah.
I'm happy.
Well, it feels like a Monday for me today, so I'll magically change a 120 to a 200 just because I feel like. Okay, so x is this. We can substitute now.
This is a helpful class right now, though.
The area as a function of diameter is minus pi d over 2 times d plus pi d over 2 squared.
Oh, dang, I know. Oh.
Simplify this. I get a 60 times d. And then let's see what we get. I get pi over 2 d squared as negative, and then a pi over 4 d squared is positive. So that must be negative pi over 4 d squared.
Wonderful.
That's d, not a 0.
It's not 600, that's 60D. That's why I chose a letter that looks like 0.
Exactly. I like the, looks like zeros. X is something you can't make a mistake with. Okay. So,
I should press the button next time.
No.
now what? We've got our equation, now what?
Well, I don't know.
Don't we set it
Or
equal
domain.
to?
Oh yeah, we need domain.
So we need a domain. So a variable, independent variable is d. So d is an element of what interval of values?
0 and 120.
In some sense, d could be almost 0.
Yeah,
We really would want to include that, I guess.
almost 0. And
What's the
then
maximum d?
almost 120. Come on, come on.
Well, if d was almost 120, then you would be using a lot more edging than 120.
Oh crap.
Well, even if it was 60, the amount of edging here would be more than 120. So what the idea was, what we did before, we left one variable be close to 0, and we left the other variable be close to 0, or equal to it if you can. So, like right here, if x was close to 0, what would, if x was essentially 0, what would d?
120.
Got a d for a 0 for d. Now I got to do a 0 for x.
Oh.
2 times 0 plus pi times d equals 120 means that d must go to 120 over pi.
So that, can we include that?
At that time, we can include the point because that's going to be a real dimension. We'll actually just get a circle. So if we just get a circle, then the d could be 120 over pi. And we can actually include that point. Okay, so now we have our objective function. We have a domain. And what's next? Find critical values and test critical and endpoints. So we'll find here a prime of d is equal to 60 minus pi over 2 d. So critical will mean a prime of d equals 0 or a prime of d equals does not exist. And this one doesn't happen. This one, d is equal to 120 over pi, I guess.
Mm-hmm.
So we have to now test endpoints and critical values.
Dang.
So endpoints I have as 0, but it's not included, so I have to do the limit as d approaches 0 from the right, a of d. Then I have to do an evaluation of a of 120 over pi. Happens to be an endpoint and a critical value. So we got endpoints and critical. Critical value is an endpoint this time. So I really only need to do it once. I'm not going to do it both. This is the same. So I have to evaluate that. I have to evaluate the limit. So back in the original function over here, a of d, as d gets close to 0, where area gets close to 0, looks like to me, so that goes to 0. That's certainly not going to be the maximum area. And then the critical value and the endpoint can be substituted in and calculated. And that's going to form just a circle, so it's just pi r, it should be just pi r squared, right?
Yeah.
We'll just put my area functions. 60 times 120 over pi minus I over 4 times 120 over pi squared.
Where do you get that equation?
From,
The AD equation?
yeah.
Okay.
So we gotta go calculate that, I guess. I had to do some exact math. So this would be 60 times 120 pi, 60 times 120 pi, minus, oh, yeah, 4. So we have 4. So let's make it a 4 times 60. 60 times 20. And then we've got over here minus 120 squared pi over 4 pi squared.
Where did the 4 come from? At the top?
3,600 over 5, or 1,145.
3,600 over pi, approximately what?
1,145.92.
So that would be our maximum area at this value D. So you want to kind of put it all together, I guess. What did we learn? Max area. (1,145.9) square inches. And all of the edge forms a circle of diameter 120 over pi So our end figure did not have any rectangular shape to it at all. It was only a circle, which
That's weird.
stands to reason. I don't know, and you can prove this in general theory, not just on this problem, but that the biggest bang for your buck in terms of area for a given perimeter, a circle is the most densely packed plane figure. You have the most area for a given perimeter than anything else. And the more uniform the shape, in generalization, the more uniform the shape, the better the area per perimeter. So irregular shapes like long, thin rectangles, you don't get much area for the perimeter. The square, you get a lot more area for the perimeter. If you go all the way to a circle, you get the best area for the perimeter. That's why this time, optimal answer is a circle. Rachel?
When it came to evaluating the max area behind you on that board, how did you get that 4 pi on the numerator?
I don't know. I probably made stuff up.
What?
Let's see. We'll look back and see if I did it right. I don't know. I may have made stuff up, but let's see. I had a 4 pi squared in this denominator. I had a 4 pi squared, In this denominator, I just had a pi. So in order to get a common denominator of 4 pi squared, I needed a 4 pi in this numerator.
Okay, so it was added in. It was made up.
Does that make sense now? I was trying to write it as a combined fraction.
Okay, I'll take it.
So the other one Joe asked for was, which one, 33? 33, let's expand the directions. Directions 31 to 34, find the point on the graph of the function f that is closest to the point AB by minimizing the square of the distance from the graph to the point. I remember we did one of these. Might be necessary though, because it's quadratic. Okay, so 33, x squared minus 2x plus 1, 1, 2. I guess I'll start right here. 3.4, number 33, f of x equals x squared minus 2x plus 1. Is that correct? So what's the point again? Okay, so I want to find the point on this function curve that's closest to that point. Just as a point of reference, I guess I'll see if I can graph that. I don't know if I will need to. But let's see, the vertex is at 1. I guess it's something like this. And so the point that they're giving us is at 1, 2, which is about right there.
The x-axis.
So just based on the geometry, based on where the vertex of this parabola is, this point is on the axis of symmetry, on pre-calculus axis of symmetry. So I'm going to say there's two closest points. The closest point over here will be perpendicular to that curve. And over here also will be perpendicular to that. And they'll be they should be at the same height on the parabola. Same height. Okay, that's just analyzing the geometry. Okay, let's do the calculus now. So we want to minimize square of distance. What I need to do is name this point that I'm looking for. We'll just name it as x comma y. And I'm going to hope that my algebra, once I'm done, gets both of them, instead of trying to do both at one time. So the distance between these 2 points squared, so distance squared is, x minus 1 squared plus y minus 2 squared, is that right?
Yeah, sure. Yeah, that's it.
Pythagorean theorem? You can go back to the distance formula, but this is just Pythagorean theorem, where the dashed green line is the hypotenuse, so you're going over x and down y. Pythagorean theorem. Okay. Now what? We have an equation, but how many variables do you see?
2.
Oh, constraint is, see, this is my objective right here. There's my objective. But what you don't really realize, this is your constraint right here.
What is
That tells me a relationship between y and x.
Oh.
So d squared equals x minus 1 squared plus x squared minus 2x plus 1 minus 2 squared. What is that going to be? Let's see. If I subtract 2, that makes a minus 1. This makes a minus 1. Now I got to square that. So, good grief. X squared minus 2x minus 1. X squared minus 2x minus 1. X minus x squared. That's not x.
Hang on.
X.
Wait.
X squared
Wait.
minus 2x cubed
Oh, I got it. So he's just adding.
minus x squared
But no, that doesn't make sense.
minus 2x cubed plus x. So there's an x to the 4th minus 4x cubed plus 2x squared plus 4x plus 1. I got it.
Okay, what just happened?
Gonna add that.
Oh. I thought I understood it.
So if I combine like terms, I get x to the 4th minus 4x cubed plus 3x squared plus 2x plus 2. There we go. Question? Did I do my arithmetic wrong?
Actually, can you go back, please? Mr. Senor Gaddis? What is that thing on the right?
What?
That thingy on the right.
What thing on the right? This
With
thing?
the on the board with the 2 lines on it and the
Squared if I multiply.
You're talking about this thingy right here?
yes.
I was just multiplying.
Is that long multiplication or whatever
That's
it
just
is?
multiplying polynomials. I mean, I just multiply like you did in 3rd grade when you multiply 27 times 51. You put a stack and you do all kind of. I just did the same thing, right? Multiply each term times each term.
Did you just square what was on the inside?
It
Is
is.
that all you did?
Yeah, I just multiplied what's on the inside times itself. So I just multiplied.
Okay, then where's that negative 2x cubed coming in?
Well, negative 2x times x squared gives me a negative 2x cubed.
Oh, okay.
Negative
You
2x
know
times
what?
x squared gives me a different.
Yeah. Okay.
The technique for distributing each term to each term. That's all.
Okay.
Not the only way. Some people do something called a box. I don't know how to do a box, so I just do it this way. Whatever it takes. If I did all my multiplication correct, and if I combine like terms correct, this should be my equation. But I mean, double check. It is
Negative 2.
negative 2. This negative 2?
I see where you square the
Talking about this negative
x
2?
square, but.
Well, this negative 2 and that plus 1 makes a negative 1.
Oh, okay.
So I got a negative 1 here and then a negative 1 there. So I combine those before I square them. Let's pretend it's correct. It may not be. I think it is. But
I just remember you playing basketball. That's funny. When you laying up, just juking Malcolm. Slammed. Okay.
Now we've got a nice little location.
I don't believe I played this.
We have our constraints.
are we feeling like this? Everyone had a chance to check it over and see if my algebra is right?
I'll
For
take it.
you. Okay. Got one vote of confidence. I feel a little better now. I need another vote of confidence so I can move on here.
How does he want me to check it?
I think it's correct. It's not that I couldn't make a mistake, but I think I did it right. So the domain is what? Domain is the x values. So what can my x values? What range of values could x take on here potentially?
Is it infinity?
Real numbers. That's right. Any real number. So from negative infinity to positive infinity. That's not going to be very helpful because I can guarantee you that negative 100 million is not the correct x and positive 100 million is not the correct x. So those aren't really helpful to me. Let's hope we can find a critical value. So we're going to take the derivative.
Oh, that's cute.
But don't we have to take the square root?
Oh, yeah, don't we have to take the square root of the thingy?
Why would we want to do that?
Because it's 8.
Raise your question again.
Well, one of my classmates just thought that the square is like the distance or whatever, so you'd want to square root it first.
Well, correct. The actual distance is the square root of the number. But if you minimize the square, you will also at the same time minimize the square root.
Okay.
If you
Yeah,
minimize the square of the distance, you'll be also minimizing the actual distance.
Mhm.
So it's just easier for derivatives to leave off that square root if you can. Sometimes you can't, but this time I think you can. And I think that's what they said, minimize the square of the distance. So the derivative is 4x cubed minus 12x squared plus 6x plus 2.
Oh yeah, it's not like I have to do it every waking hour of my life. Every morning I wake up and I think of derivatives.
Now I'm kind of stuck.
Oh no.
Oh no.
I have to find when is that equal to 0.
I'll tell you what though, it's never not gonna exist though.
I agree with you there. How do you know that?
Because it's a polynomial function.
Oh, no. So how am I going to make it set equal to 0? What am I going to do?
Set it equal to 0. Come on. Right? That's it. Yes. Yes. Yes.
What now?
I said to set equal to 0, which you did on the board.
I did that. Okay. Now what?
Well, you want to move the 2 over?
2.
Or do you want to factor out a 2?
Yeah.
It's your choice.
Factor out the 2.
I would definitely not move the 2 over because the whole idea is if you can factor, you want the factors to be set equal to 0. I'm not saying I can factor, but anyways, I could divide a 2 out. You're right. So I divide everything by 2, including the 0, and I get 2x cubed minus 6x squared plus 3x plus 1 equals 0.
Yay. Now what? Oh, are we going to do it now, Sammy?
And what are we going to do? That's my question. I'm not seeing an easy factoring of this.
How do you factor trinomials anyway?
Terms.
You could group it like, okay, one thing you could try to do that looks like it's promising, but I don't see it working. Is I could group, say, these two together. And group those two together. Maybe it'll work. See if I can factor something out of each group. Well, this group, there's nothing integer-wise I can factor out. This one I can factor out, say, a 2. In fact, I can factor out a 2x squared. So I would get what is that? X minus 3?
I forgot grouping. You know what? It works to me.
But that doesn't really help me because I still don't have a factor, and I have just a plus sign right there.
You could factor out an x minus.
Hey, when all else fails, resort to technology.
I got you.
You got me covered.
I got you. An hour.
Justin's been there for 10 minutes. Like, come on, man, just call him. What is it?
All right. One of the x's is 3.53. I got 3.4. I guess you round to 3.4. So it's negative 0.63 and then 0.23. Rounded up. That's why I just let it 3.4.
Wait, why do we have 3?
What is it?
This is trinomial.
That's not what I got.
It's trinomial, so we might have 3. What was the other one?
That's wrong.
What did you
No.
say?
Last one got 0.23.
Go lawyer on it.
Okay.
That's not what I got.
You gotta point your
That's
finger.
all you got. Okay, what did you get?
Hold on.
Mine ain't right.
Different answer then.
I got that x equal to 1.
Oh, thanks.
Exactly 1?
Yeah, exactly 1. And then x was also equal to
Oh, never mind.
Negative.
See what I did. What's-
point.
What was that, Chloe?
The next one was negative 0.2247. And the last one was 2.2247.
Yeah, that's right. I missed the first one.
Okay. Oh. Well, now what?
Well, you put them in.
That's right. We got to test the endpoints, which are limits, which are going to be infinity. So I'm going to skip it to save a little time. All we're going to do is plug in our critical values and see which ones of those are the minimums, if any. So we have to go back to the original d squared. So we have to do d squared of 1. So then we have to do d squared of negative 0.2247. And we have to do d squared of 2.2247.
Actually, that kind of makes sense with the graph. Right? Dang.
1. Maybe I can do the 1. That's the 1 minus 4 is negative 3, plus 3 is 0, plus 2 is 4. So that's equal to. Okay, I got that one for you. Let y'all do the technology on the other two. Did I get a d squared for the first one? Negative 0.2247? Okay, what's the other one?
I remember that. It's negative 0.000. That's what it's.
That feels a little funny to me, but what did you say? Negative point. 0, 0.
I got 1.5.
Something seems not right there.
I got
I got
1.75.
1.75
Which one?
for both of them.
I was gonna say, those two should be the same.
Can they send me from
Yeah,
that
I
camera?
got it.
No,
Why not?
because I'm like that. It's on.
Or is it just
Oh, come on, Josh.
Niner or something else as well? Oh, okay. Hey, I'm not the only one that makes them, that's okay. All right, so, what's fun here? We said the geometry, we expected 2 points to be the minimum distance, and we found 2 points. Both of these are the overall global minimum. That one is not.
Oh my gosh.
So
There's one.
here's point. Those points are
Points are.
negative 0.2247, and then I need a y value that goes with that, and 2.2247, and a y value that goes with it. So where do I get the y value for these? I need a order pair, a point.
Do you just plug it into the original equation?
The function, right? I want points on the function, so I'm going back to f now. So I use the f function over there. And like 3 or 4 different equations up there. You got to keep track of which one you're plugging into.
Crap.
No. These came from the original distance equation, but now this, these are points on the. So these are points. Here's points on the function. You got to find points on the function.
Yeah.
5.
Yeah.
This should be 1.5, shouldn't it? Pretty certain, based on the symmetry of parabolas, they should have the same height. If they don't, then we did something wrong. Okay, well, that was a good problem. Wow. I need to go rewrite my test with that one on there now. That's all.
That's pretty good.
That was a challenge.
Hopefully he puts that on the test so I'm prepared for
We're
it.
running a half marathon in the morning. Man. Just get up and get going.
You want to do soda cans?
But what else do you want to discuss? Anybody else have other problems? Joe asked a couple of good ones. Anybody else?
Yep. It's just the soda that bothers me. Y'all want to do a related rates problem?
Yeah.
Josh, you have your question?
Please related rates, y'all. I need one more example of that.
Never mind.
Can we do 43 and 3.5?
Thank you, Chloe. How fat is the?
Never mind, 43 on 3.5. Okay, directions. Consider a large helium balloon that is being inflated at a rate of 120 cubic meters per second. How fast is the radius of the balloon increasing at the instant that the balloon has a radius of 12 inches? So, 12 inches and 120 cubic meters per second.
Oh yeah. I have a chocolate bar in my car from like that. Crunch.
Where'd
Okay.
you get it?
My mother.
So this was 3.5, number 43, is that what you said?
Bring it to my table.
Oh yeah, you're right.
We're given,
It's a very small one, but very small.
I was using color before, but I'll just skip that there. So given
I have two.
that the rate of change of the volume, 120 cubic centimeters per second.
That's a lot of centimeters. Dang.
It's inches.
Inches.
Why is it centimeters?
It's inches.
It is inches? Okay.
Yeah. We start using imperial measurements in this. We American.
Okay, we want to find the rate of change of the radius at the time that the radius is 12 inches. So that's given information and the defined information. Talking about a sphere and so the volume of a sphere. If I remember that one yet?
4/3 R pi. 4/3 pi. What was it? Yeah.
Pi r cubed. Interestingly, when you're in 3 dimensions, it's a cube of r. When you're in 2 dimensions, it's the square of r. And when you're in 1 dimension going around the circle, it's the first degree of. Okay. So 4/3 pi r cubed is the volume. Ready to go. So that means if we take the derivative of this with respect to time, then I get dv dt equals 4/3 pi is a constant multiplier, so I can pull it off and have 3r squared dr dt. But the 3's can cancel, so I get 4 pi r squared dr. And I'm trying to find dr dt, so I'm going to solve this equation for dr dt. So dr dt is equal to dv dt divided by 4 pi r squared. So now I'm ready to evaluate it at the given number. So this is equal to rate of change of volume, which is 120 inches cubed per second, divided by 4 times pi times radius, which is 12 inches. So what is that? 10/36 pi. So divide by 2 is 5/18 pi. 5/18 pi per second.
I'm hungry.
24.
21.
Ready? All right?
What? That does not look right.
I see the square inches on the bottom, so it makes 6 inches.
Yeah, the good question about the units of measure. We had inches cubed per second in the numerator and inches squared in the denominator, so that would cancel to just inches per second. I don't know, is that not right?
I don't know why you're
5/4. Uh-oh. Let's check this again.
Oh my gosh.
Oh, yeah, 12 times 4 is not 36. 12 times 4 is 48. Ah, right.
Wait, what happened?
You did just simplifying.
I multiplied 12 times 4 and magically got 36 instead of 48.
I trusted you. I thought you were infallible, Mr. Gaddis.
Well, I appreciate the vote of confidence, but I wish. Okay, so questions on that one?
I had a question.
Yes.
There's
Yes,
something about that process that I never got. When you take the volume of the sphere and then you find the derivative of it for t,
Yeah.
and on the right side, and you do that stuff, why do you multiply that dr over dt at the end? I never really got that part.
That's a good question. Anybody else able to remember what we said about that? This is differentiation. That is correct. If you, for example, had when we did some stuff before, and you had like x squared plus y cubed, and you were doing the derivative with respect to x, this one's just 2x, but this one we did implicitly as 3y squared times dy by dx.
Mm-hmm.
It's called implicit differentiation.
Yeah.
Well, the same idea here. We've got volume equals 4/3 pi r cubed. And when I differentiate with respect to time on both sides, both of these variables, see up here, x was the variable of differentiation, and y was an implicit function of it. Now, the variable of differentiation is t, so both r and b are implicit functions of t. So we have to do implicit differentiation. Derivative of b is dv dt. And then over here, you've got this r cubed, just like up y cubed, so that gives you the 3r squared. And then just like up here, you get dr by dt. So it's implicit differentiation is what's happening there. Does that answer your question?
Okay.
Okay.
And you said the 4/3 is just a constant?
The 4/3 pi, that's, yeah, we had a rule in derivatives. If you're multiplying by a constant number, then you don't have to worry about differentiating it. And you can do a product rule. All right, I mean, if I'm doing the derivative with respect to x of 4x, I could, if I wanted, or whatever, 4x squared, I could do a product rule. And you'd have a derivative of 4, which is 0 times x squared, plus 4 times the derivative of x squared, which is 2x. So since the derivative of a constant is 0, then we just don't even do it, and we just say, well, let's do the derivative of the x squared and multiply by that constant. It's called the constant multiple.
Okay.
4/3 pi is a constant number. I can find multiple. Josh, you have a question, I see?
I had a question on number 47. I was wondering if we could go through it real quick.
47 on 3.5?
Yes.
Okay. Suppose that Stuart is 6 feet tall and walking towards a 20-foot street light at a rate of 4 feet per second. As he walks towards the street light, his shadow gets shorter on the 47. How fast does the tip of Stuart's shadow move? Over here. Okay, so the picture is something like this. We have a street light, 50 feet. Over here somewhere is Stuart. Stuart is 6 feet.
Dang.
And the street light causes a shadow.
Oh, wait, 1 meter. I don't know.
2 meters? 2 meters.
So we'll call that shadow, and call that x is distance from the street light. What were we given? Besides that geometry, we were given his rate of change walking towards the street light at how fast? Right? So if x is his distance from the street light, then dx dt must be what number?
4.
-4. negative 4 feet per second.
Wait a second. Oh,
Why is it
get
negative 4, not positive 4? They said positive 4 in the book. It's shrinking his distance, and the only way you shrink distance is you have a negative rate of change. We're supposed to find what?
How fast is the shadow changing?
Yeah. Is it the length of the shadow, or is it the tip of the shadow? Tip of the shadow. So we actually kind of need another variable in there. So this distance all the way out here, the tip of the shadow, call that t. Find dt by t.
Dude, DT, he's an alumni.
What does it say? When do we want to find that? Doesn't say. Well, that answers the second question. On number 47, the second question is, does it depend on how far Stewart is from the street light? I'm going to say no, since they didn't even give me that number. Well, we can see that here in a moment, hopefully.
He's moving towards the lamp. X is shrinking.
Okay. Any ideas? How are we going to set this up?
No, I don't. Gosh. I think it's going to have to do with phi, which mildly irritates me.
Now let's see, what do we got? We got maybe t over 20. And that would be s over 6. Okay, so then that's s over 6. I agree with that.
Mm-hmm.
The only problem I see is, and that's fine, so far so good, just by similar triangles. The only problem I see is I'm not giving anything about s, I'm giving something about x. So, and I want to find about t. So I need to get s in terms of x.
Oh, well, are you going to do a relative triangle dingy?
Yeah, so what how can I rewrite s in terms of x and or t? Yeah. This is just t minus x.
Oh, that's cute.
What I would do is I would rearrange this equation to get t on one side and x on the other, just to make my life easier, I suppose. So let's say we cross multiply to get like 6t equals 20t minus 20x. You've heard that term before, cross multiply, does the proportions being equal. So what is this? Negative 14t negative 20x.
Mm-hmm.
Or I could even say that t is equal to, let's see, 20 divided by 14 is 10 over 7x. So now if I differentiate, I get dt by dt. So I'm coming over here now and I'm differentiating, is equal to 10/7 times dx by dt. Well, that gives it to me right there. So the rate of change of the tip of his shadow is 10/7 times the rate of change of his speed walking. So this one is 10/7 times negative 4 feet per second, which is negative 40 over 7 feet per second. And the answer again is emphatically no, it does not depend on how far away he is from the lamp. If it had depended, let's review real quick. How much time? I meant, okay, we got time to review. So it doesn't depend on it because it didn't even give you the number. But if you look at the equation, how can you look here and tell me it doesn't depend on his distance from the lamppost? No X in it. If there was an X in this equation, like there was an R squared over there, then it would, over there, it depended on the radius. Here, there's no X, so it doesn't depend on the distance. That's how you can tell. Yeah, 5 minutes. Another question real quick, anyone? Josh, did it answer your question?
Yeah, but you can always do another one. 51.
One?
Yeah.
Freaking Josh. Your expectations are too high, son.
I mean, you could do another.
Oh, wow. This looks like a fun one.
That's a big one.
So we got a 12-foot ladder against the side of the house. Trying to sneak into her upstairs bedroom.
She's a Lena, man.
Unfortunately, the ground is muddy because of a recent rainstorm. The base of the ladder slides away from the house at a rate of a half a foot per second. How fast is the area of the triangle formed by the ladder and the house ground changing when the top of the ladder is 6 feet from the ground?
Yeah, I mean,
Okay, let's see if we can find a spot real quick to get this knocked out.
what is this, boxing?
So we have a ladder. Ladder is 12 feet. We'll call this maybe X and this Y. What's given? As a radius. Given what? Sliding down at how fast? So slide down. So what would that mean? I'm going to have dy by dt is negative 1/2 foot per second. Okay? What are we supposed to find? We want to find the rate of change of the area of the triangle when what? When, so what variable is that going to be? Y equals 6 feet. Okay. I'm reading, that's what we got to find. Questions, suggestions? I need an equation relating area and y somehow. So
Bless you.
area of that, what's the area of that triangle? 1/2 x times y. I agree with that. Good. How many variables do you see there? 2. So I got to replace one. So how do we do that? We got to do something to solve, I guess.
Pythagorean theorem.
So let's see. X squared plus y squared equals 12 squared. So apparently y is, wait, we want x. X, because we're trying to solve for y here. So x is equal to the square root of 12 squared minus y squared. Oh. Okay, so now I have area equals 1/2 of y times the square root of 12 squared minus y squared. Okay. Over.
What do you want me to do? Implicit differentiate that?
Oh, we need to implicit differentiate that. Okay. A by dt equals 1/2 of, now what? 1/2 is a constant, so let's pull it out.
Yeah. Are we gonna have to hide?
Yes, but before that, you're going to have a product rule.
Crap. Oh no.
Derivative of y is dy by dt times the square root of 12 squared minus y squared plus y times the derivative of that stuff, which is 1/2 of 12 squared minus y squared to the negative 1/2 times negative 2y times dy by dt.
Because of the Hein. And then because of the implicit differentiation. This is
That's what we
getting,
double chain.
it's a double Hein.
Okay, so this is really fairly simple now, folks. All you gotta do is plug in. I mean, I could try to clean all that up if I really, really wanted to, but I'm asked to find dA dt. There's dA dt. Evaluate y equals 6 when dy dt is this. Well, everything I see is y's and dy dt, so it's plug and chug. Whatever that comes out.
That's Woody Madison's old
Dt.
place.
Evaluated at y equals 6. 1/2 times dy dt is negative 1/2 times the square root of 12 squared minus y is 6, so that's squared minus 6 squared plus y is 6 times 1/2 times 12 squared minus 6 squared to the negative 1/2 times negative 2 times 6 times dy dt is negative 1/2. Plug all those numbers in and come up with a rate of change. You follow that now? Let's leave it over there for a minute. You all follow that? Josh, did that answer your question?
Yeah.
Josh, are you pleased?
Okay, so plan for tomorrow is a test and allow the usual 15 minutes extra.
Mr. Gaddis.
Negative 0.9. What do you think about that? What does that mean?
Tell them that.
That's not the answer.
That's not the answer?
The book says the answer is 6 square feet per second.
Well, then something's wrong.
Yeah, you're right. Because 0.9 is not 6. Crap.
Well, I agree. I'm not saying which one's right, though. I'm not saying the 6 is necessarily right. Possibly. I'm not saying the negative 9 is necessarily 0.9 is right. Could it be? My question is, could it be negative? What would that mean if it's negative?
Negative prime.
Well,
The area is getting smaller.
The area is getting smaller. If this was right, the area is getting smaller. It doesn't mean the triangle is negative. It's change in area. So it could be that it's a negative change in area. Now, that doesn't guarantee that the negative 0.9 is right.
I'm just stuck in an epistemological vacuum right now. I don't know what's right or what's wrong. Dadgummit.
Oh, but nature hates a vacuum, so let's get away from that before it sucks all our brains out.
Oh yeah, I had a quick question, Mr. Gaddis.
Good question. Okay.
Lose our connection.
About to lose, quick.
Is calculator yay or nay for tomorrow?
Calculator is yay,
Yes.
but you do have to show me your calculus work. You have to show me, because I understand there's different ways of getting the answer, but on this test, I'm testing you on these two techniques. So you need to be able to show me the techniques as well as the
This time.
Yeah.
I apologize if you get that right. We're out of time. We're about to lose connection. We'll see you tomorrow.
We need to ace this up to save the grade. This is worth studying a lifetime for.
I'm going to wait through it one more time while we're running out of time.
Yeah, you know what we should do?
guys.
What is that?
Can I get a chocolate?
You're coming to 1, I think it's 8.
Don't see this. It's a 5-minute hiatus.
Wait, where's that?
Why would you do that?
I need a chocolate bar for my car.
That's fine. Rizzo,
Yes.
Yeah.
you're done.
You can do this, Josh. I believe in you.
I already got all freaking day.
Are you done with that?
Yeah, I don't see why not.
I'm already here.
How long are we staying?
2 minutes.
It depends on how long it takes you to get your shirt made.
Is that all we're doing?
Yeah.
I don't have it all cut out yet.
Well, yeah, I'm out.
So we're gonna take a paper cutter down there and we're gonna take iron.
Good time right here.
Yeah. It's gonna be a paper cutting ironing day.
On my shirt.
Wow, that's ironic.
Those pictures of the guy I was showing you.
I knew you were gonna say that.
And you can't mess up. Stanley stuff,
Yeah, I
it's
know.
too expensive.
So people aren't
I
going
would
to
marry
just
DJ
shirts.
Watt.
We're gonna make all of them. We're gonna make the ones that people signed up
He's
for.
just in a relationship.
Sammy!
Well,
You never know what you
she's way better than I am.
Yeah.
Like, so. Player and everything. I'm just saying,
Hey, Brittany.
like, you know, one day
You should come with me to my car.
I walked, one day I took the stairs. You could say that
Are
was.
you not a big boy, Rizzo?
Huh? What'd you
Are
say?
you not a big boy?
You walked.